your generation capacity, it's about your ability to act as a load. And that's going to become really important, because if you don't have flexible load that consumes surplus, the investors in new variable renewable energy will have commercial limits on their development opportunities. So you may not actually be able to get enough generation coming into the system unless you can work out a way to store it. Because if you can't store it, you'll place constraints on their output, which then negatively impacts their business case. So you're going to end up in a situation, if you can't work out efficient ways to store the excess, you're going to bring the shutters down on a lot of that new investment at some point in time in the future.
Is that where the New South Wales link will improve? So solar cells in South Australia can supply...
Yeah, interconnection is about diversity, and we'll talk about interconnection in a second. So yeah, interconnection is a really important part of this solution. You know, our view is the power system won't be able to operate with these new technologies unless we have more interconnection between the regions. We're going to need to be able to shift that energy around the system a lot more easily than we can at the moment. Yeah. At the moment, our interconnectors are all just very, very flimsy strings, largely. They need to be made into very tight, very heavy sailing rope. Okay. The proposition for Tasmania is that we've got a significant hydropower system already. We use it for energy mainly, whereas if we were closely connected to Victoria, and there are more sources of energy for Tasmanian consumers to access, we could use that hydro system in a very different way. We could use its flexibility and we could use its storage to perform some of those new services that we've been talking about for the last half an hour. And we'll talk about the interconnection issue in a second. Our natural topography, we have very steep hills with flat tops. So, and we have existing assets, which provides us with what we call long duration, greater than 12 to 14 hours, cost competitive pumped hydro opportunities. This steep hills, flat tops is actually really important. So, and I'll show you in a second, if you've got an existing reservoir that's been built for energy, so it's very big, and it's been built there for a reason in the first place, because there's really steep hills and it's a valley, but it's already there. On top of those hills, we're very lucky that there's flat tops. And flat tops, if you like to build what they call turkey's nest reservoirs, you'll love a flat top, because it's easy to build a turkey's nest reservoir rather than build it on some sort of hilly territory. So we have really, really big lower storages. We have really steep hills, which gives you a high efficiency factor when you come to pumped hydro development. And we have these flat tops that allow you to very economically build enough storage. So that's thumbs up if you want to develop pumped hydro. We also have all the electrical infrastructure because it's already there because we've got traditional hydropower. So when we talk about strengthening the transmission system for this sort of investment, we're not talking about building new transmission lines, we're just talking about making the existing ones bigger. And that's really important because you're not going out there trying to find whole new easements for new transmission lines, which is a whole other story. And we've talked about the many gigawatt hours of storage that's going to be needed. And interestingly, we've got excess capacity already because we're not a capacity constrained market in Tasmania. We're an energy constrained market because we're mostly focused on water. So, for example, in Victoria, and you guys felt it as well at the end of January, you guys had a few issues due to the way the power system was working with the hot temperatures, and there was load shedding in Victoria. I'm not quite sure whether you had load shedding here, but it was definitely in Victoria. At that point in time, we had over 450 megawatts of capacity sitting in our system unused. So the water was there. We could have turned them on for that 4-hour period if you had had another interconnector. So that requires no investment in our hydropower system because it's just there. We've got more capacity than we need. And the way to explain that is that we've got about 2,400 megawatts of hydro on its own. Our maximum demand is in the winter, not the summer, which is about 1,800 megawatts on a really cold June morning. Our demand usually is around 1,400 megawatts, usually. And in the summertime, it can drop down to 800 megawatts. So quite often, we'll be sitting in summertime and we'll be pumping 500 megawatts across Basslink into a really stressed Victorian market, but we still have another 400 or 500 megawatts of capacity that could be turned on, which is good, but that you can't get it to the market. So it's not just about the new investment in pumped hydro, it's about better using the current investment in the hydropower system in Tassie. That is Lake Gordon. That's our largest reservoir. It's about 25 times the size of Sydney Harbour. For any of you civil engineers, that's a double concave dam. Sergio Giudici, if any of you guys would know him, designed that dam. It's a masterpiece. It truly is. I'm an electrical engineer and I think it's amazing. You can actually abseil off that dam too. It's a 140 metre vertical drop. So once you leave the top, because it's a double concave dam, you're basically free falling from the top.
Is that similar to the Hoover Dam in America?
No, different design.
Oh,
this one curves that way, and it also curves that way. So the water actually pushes the dam. I'm not a civil engineer, so the pressure of the water actually pushes the dam into the sides and creates the strength in the dam. It's the highest double concave dam in the world, 140 something metres. Yep, so when you're standing at the bottom, you're actually under the dam. It's quite cold and wet usually as well. I'll just do a quick video just to spice things up a bit. And unfortunately in this video, I'm there. So you don't get away from me that easily.
Power station. It's a 90 megawatt power station that was commissioned in 1938 and cannot be controlled from Hobart. So if any changes to load or starting or stopping machines is required here, we have to do it manually, which is what I enjoy. The hydro is part of my life. I was born into it. I'm now back working on assets that my father worked on building the support structures for. It gives you a sense of pride to belong to this.
It's almost like the Tasmanian landscape was made for renewable energy development. For over 100 years, we've relied on our water resources and our topography for quite an extensive hydropower system. Just recently, over the past few decades, we've started to invest in wind development as well. On top of that, we've got a lot of opportunity to invest in pumped hydro technology in our hydropower system, which would allow us to use our water storages more flexibly and also allow us to bring power back into the system when it's most needed in the future. In essence, those attributes really describe the battery of the nation opportunity. So the ability to utilise the existing hydropower system as well as invest more in it, the ability to unlock the significant wind development opportunities on island, and that all can come together if you have more interconnection from Tasmania to Victoria, because that's the market that's going to need a lot of this new energy in the future.
TasNetworks, we like the transport company for power. We're currently working on the feasibility and business case for a second interconnector between Tasmania and Victoria, which will unlock Tasmania's renewable energy potential. The reality is that extra hydro capacity is only required if you've got more interconnectors. So if you can actually send that energy to the rest of Australia. And similarly, another interconnector is only required if we have that dispatchable and renewable energy. So the two projects are very complementary.
We've used hydropower to lift the economy and lift the living standards of Tasmanians over the past decades. Many people in Tasmania are very excited about the prospects of being back in that game, of building assets here in Tasmania. But the difference this time around is that we're helping the country meet the challenge of how to decarbonise the power system.
What I like about it, what excites me, is it's just leveraging off what we've done for 100 years. When you look around Tasmania, look at all of the lakes and the amount of water we've got heaps and heaps of batteries already. In essence, it's really now an opportunity on how we can work that all together and make some other changes to get best use out of those batteries.
The battery of the nation idea isn't just about the new pumped hydro development opportunities, it's ensuring that our existing assets that have served us so well for many decades are also fit for purpose for the future. And Tarraleigh is a great example of one of those assets, but now we have quite a significant market opportunity to develop our assets even further for the benefit of both Tasmanians but also the mainland market as well.
I'd like to see Tasmania deliver more power to mainland Australia. Every little bit we can do to help, I think, will make it a better place for the future generations. This is Tarraleigh Power Station. It's 90.
Once is enough. Well, I can listen to Bob forever. Bob's so passionate about the hydro, and if you hear his story about him and his father, and they pretty much moved from one construction scheme to the next over many decades. It's quite an amazing story, and for him to be able to do that and to be on a video that's being shown all over the country is, he's super proud, and he should be. Audio. Let's get into the Tassie opportunity in a bit more detail. So we've got thousands of megawatts of pumped hydro storage development potential. And it's all very, very well priced. So if anyone knows that some of the prices that are going around for pumped hydro development in Australia, our numbers are at the bottom end of that curve, and our storage durations are at the top end of the curve. So you're getting good dollars per megawatt as well as high storage durations. Putting aside Snowy 2 because it's an outlier with 170 hours of storage or whatever it is. Significant wind development potential in Tasmania. So you can't develop it now because you don't have a customer to sell to. And we'll talk a bit in a second. It's actually very complementary with South Australian and Victorian wind because it blows at different times. We spoke about the latent capacity that's in the system, and we've spoken a little bit about the ability to actually use that storage and dispatchable capacity that's already there in a different market context. And that's basically, if you're not using it to be providing energy all the time, you can hold that water and you can use it when the market needs it the most. And you don't have to pump because it's already there, but it falls from the sky. And it's got usage patterns that complement the rest of Australia. And we spoke a bit about that in terms of our seasonal demands are the opposite to the rest of the country, particularly Victoria and South Australia. Rightio. So what we did was, we said when we started this project, let's forget about one interconnector. Let's just have a look at if there was no interconnection constraint, how much development opportunity in terms of the resource is in Tasmania. And then we said, then let's overlay the interconnectors on top of that. And we surprised ourselves because we actually had a bit of an internal argument as to whether or not we should have put another interconnector in here as well because of the size of the opportunity. Now this is driven by the fact that you have so much pumped hydro development opportunity on island and you have so much wind development that if you were to develop all of it over the next 10 or 20 years, you'd need probably about 4 new cables. So no one's suggesting that we're going to be building 4 new cables in the next 5 or 7 years. The good thing about this is that it actually can be staged. If you need the next interconnector, well then you build the next interconnector. That triggers the investment in Tasmania based on the market need, and you can then just make an economic decision as to when each interconnector comes up. But interestingly, if you did all of this, you'd still only need about 20% of what the future market's going to need, which is a bit of a scary prospect when you think about it, because those numbers are pretty big. Do I need to use this?
Yeah.
Yeah? Okay, thank you. I thought I'd better check because I wasn't there. I was just waving it around. This is this progressive investment sort of idea. So this is illustrative only, but you can see how if you get a business case to build another interconnector, it triggers hydropower development, pumped hydro development, and it also triggers significant wind development in Tasmania as well. And you can stagger them. So based on the transition that the country is going to go through, you can make economic decisions probably sort of every 7 to 8 years about whether or not you think it's going to make sense to put the next interconnector in.
But what's the longest lead time? Is it
Cable.
pumped hydro?
It's cable.
The cable?
It's cable.
Oh.
There's a bit of a oligopoly on cable, HVDC cable manufacturing. We'll get to that in a second. Yes, the biggest critical path is the cable. We talked a bit, here's the graph that shows you the bit about the wind potential. So this shows you the South Australia and Victoria have relatively high correlation in terms of when the wind blows because it's on the same weather pattern. That's sort of not great because it means you've got lots of energy all at once and then when you don't have it, you don't have it. If you throw in a whole bunch of Tasmanian wind, you get diversity in when the wind blows. And from a system design perspective, that's actually really valuable because it means overall you need to build less assets to supply the load. And if anyone's been to the west coast and the northwest of Tassie and you've seen the trees, you'll know what we mean when we talk about wind in Tasmania. I think the farmer who's building the Granville Harbour wind farm on the west coast, he's lost 3, in the last how many years, he's lost 3 clotheslines that they've just snapped in the middle, gone straight over. He's building a very large wind farm on his farm. I thought I'd throw this in because it's an interesting one. When you talk about delivering new firmed energy into Melbourne, because if you on the premise that you need to replace the coal-fired generation, we did some analysis based on all the different technology sources we thought were available to Melbourne, and we wanted to see where the Tassie options stacked up, including the cost for interconnection. And we won't go into the details too much, but these 2 bars down the bottom here are the 2 Tasmanian development options, and they only differ based on how much you repurpose the existing hydropower system. Does that make sense? And the numbers are relatively low. They're only 12 or 8% shift in terms of use. But all of these above here are Victorian options, and they can be backed by gas or wind or batteries. Sorry, backed by gas or batteries or a combination of the 2. It just goes to show you, and this includes the transmission costs. And the reason why it looks like this is because when you look at the actual costs that make up these stacks, the two biggest factors are the cost to build the new energy and the fuel cost of firming. So if your fuel cost is zero, you have a very big competitive advantage. It's not, the transmission isn't the predominant factor when you look at the total technology stack. And that's why we think this is actually a pretty good idea. Oh yeah, I'll get to the interconnector. Now these slides are from TasNetworks, so I don't work for TasNetworks. I'm not part of an M&SB, but I did ask them if I could use these slides, and they said that was fine. Just don't say anything controversial, Chris. They said stick to the pitch. Okay, so that means I'll basically just anything I say in the next 3 or 4 slides. Anyway, these guys are doing the business case assessment for Marinus. So they started off with $20 million co-funded between Arena and the Tasmanian state government. And they just got, you may have heard an announcement in February, they got an announcement for another $56 million from the federal government to keep going. So basically the results from the first phase are strong enough that the market, including the government, thinks that we need to keep going on this investment because the critical path is the cable. So if you think you want something like this coming into the market in the mid to late 2020s, these guys need to keep the foot down. Okay, so the key findings were it enables lower cost, on-demand, reliable energy generation. So it has a positive impact both on the development in Tasmania but also Victoria as well, because all of a sudden Victoria has access to cheap storage. So if you talked about firmed energy, that then has a benefit. It supports power system reliability, stability, both in Tasmania and Victoria. And that's because modern HVDC interconnection can do a lot of things that Basslink can't, because Basslink's about 20 years old now, probably even a little bit older in terms of technology. So that's a really, really important part in terms of power system security and reliability. It's feasible under a number of plausible circumstances. So what they do in these assessments, you guys probably know this, they take a whole bunch of different scenarios that they think might play out and they assess the value of an investment. The biggest message out of all of this is if you think coal-fired generators aren't going to last 50 years, you should be building this link.
Is there a regulatory mechanism that prevents Hydro Tasmania building the interconnector?
No, there's not. It'd need to be, well, if Hydro Tasmania were to build it, it would be a merchant link, not a regulated link. If they're regulated, it's two different paths you sort of go down for interconnection. And I'm not going to go too far into this conversation because I'm not there, but you either build a regulated link or you build a merchant link. It's very, very difficult to build, I'll just say it's very difficult to build a merchant link in the market. There's lots of different reasons for that, and I won't go into it today.
Yeah, I understand.
But the market, generally speaking, and TasNetworks have formed this view, that the best outcome for customers is if it's a regulated link. Yeah.
So Hydro Tasmania could build a regulated link if it chose to take on that opportunity?
Anyone could.
Yeah.
Anyone could. You don't even have to be a participant in the market now. If you think you can build a link and make money out of it, you go for it. There's nothing to stop you from doing that. Yeah. So that could be existing generator, new generator, whoever you like. Yeah. Yeah, and most of the interconnectors that have been built in Australia to date weren't built, they were built by others. But is it okay if I stop there?
Yeah, I understand.
Yeah. I don't want to get into trouble. Yeah, and basically the summation here is that you've got to build it so it's there when the market needs it. If you're late, the market pays a disproportionate cost than if you're a little bit early. Does that make sense? So if you come in a year or two early before major coal-fired retirements, the cost you pay is far less than if you're 2 or 3 years late. And I think you guys would understand that from the experience over here. This slide just talks about the technical feasibility of the project. So it is, just for you guys aware, it is undersea HVDC connection. So you basically have a converter station in Victoria and Tasmania that connects to the existing AC grid, and that's all undersea cables are HV. And when Basslink went in 20 years ago, which was the first cable, it was relatively novel for that distance, but these sort of things are being built all over the world now, particularly in Europe, heaps of them. And the problem is that there's not a lot of cable manufacturers. So it's almost like a ship got to get in line. So the earlier you can place your order, the quicker you'll get your cables built. So it is on the critical path, the cable.
Is it 10% up front? for the order?
I'm not. I don't work for Tas Networks. I'm not going to say anything about how the order process works. Look, if you're really, really interested, you may want to get someone from Tas Networks to come over and talk to you, because that's a whole other 1 hour presentation. Feasible routes. What they're looking at is either coming into Burnie or Sheffield. I won't get into why that is the case, but really a lot of the pumped hydro development potential is over here, and the wind development is over here, so it sort of makes sense. Latrobe Valley, and they're thinking about going there because you've got an existing corridor. You've got the existing corridor from the coal-fired power stations that are there that's got excess capacity at the moment because Hazelwood's gone. So there's a lot of good reasons they think. Sorry, microphone. A lot of good reasons for coming in over there, they think. Sorry.
And what about Portland?
Oh, no. Don't ask me those questions about interconnection.
Okay, sorry.
There was an early assessment of going into South Australia, but just the cost of the cable it made it too expensive. Lots of different benefits. I'll be really quick here. Economic growth, both in Victoria and Tasmania. Firming renewables. It actually unlocks renewable generation 5 minutes to go. Oh, I've got to hurry up. Anyway, lots of benefits. If you want to know more about that, go to Tas Network's site and pick up the initial feasibility report. There's heaps of it. But basically, they're trying to get this in mid-20s. Audio. I won't do this because I've only got 5 minutes. Pumped hydro, we've talked a bit about that. Let's have a look at our sites. So we came up with a whole bunch of sites in our first shortlist, about sort of 4,800 megawatts of development opportunity. And you can see a lot of it on the west coast and the Mersey Forth, which is the northwest. We just announced about a month ago the 3 sites that we think are the most attractive in terms of first mover sites. 2 of them are in the Mersey Forth, Lake Rowallan, 600 megawatts. You can see up here. Sathana, 600 megawatts with 12 hours storage. Rowallan, 600 with 24, and Tribute over here with 500 with 31 hours. So there's not a lot of sites under development across Australia with those sorts of storage durations. There's actually not many at all. Audio. These are all pictures of my team doing cool stuff. They get to do all the cool stuff, flying helicopters and stuff. This is what basically would look like for one of the Mersey Forth options. So you're talking about an existing lower storage, underground tunnelling, an underground power station with a new upper storage on. And you would have seen that video there with those really steep hills and flat tops. Effectively putting a turkey's nest reservoir in one of those flat tops. And you get quite a high efficiency rating. So our efficiency ratings are all around 80%, which is actually right at the top end of pumped hydro developments. Because we've got steep hills and flat tops, you can place it to reservoirs very close together. Sorry, I should say this is an example of Tribute, which is on the west coast. Tribute is another link between 2 existing lakes in our scheme. So basically putting another tunnel and a new power station between Lake Murchison and Lake Plimsoll that are already there. But this power station and these tunnels have a much, much higher capacity, and then you use them for pumping. You're basically using it for high capacity or high capacity pumping, if that makes sense. So this is similar to the Snowy proposal, but Snowy don't have an existing link between their 2 reservoirs. They're putting this their first one. We would be putting basically a pumped hydro scheme in parallel with an existing traditional hydropower scheme. Audio, you saw Tarraleah, so it's important that it's just as much about the existing assets as it is the new ones. Tarraleah was built in the 1930s with picks and shovels. That gives you a bit of an idea as to how old it is. It's got significant risks, civil risks that we're trying to manage because it is super old. It's quite inefficient in terms of the water conveyancing, and it's also very inflexible. So when here it is, I'll go straight here. When you release the water from Lake King William, it takes about 2 to 3 hours to get from there to the power station. Under the current scheme, because it was designed in the 1930s, you can't change your mind. You have to run it through the scheme. That's not particularly flexible in the new world. We've also got lots of asset issues with these existing canals and flumes because they're really, really old. And they're built, this one here was built right on the edge of the valley that goes into the Derwent River. So if you have, and we've had these in the past, if you have an overtopping incident that erodes away the rock fall beneath the thing, you actually will get a catastrophic failure of the canal, and it actually collapses into the lake, into the river below. And we've got photos of that happened in the 80s. The last time it happened was in the 80s. So it does happen. It's not good. It's expensive, and it's not good on a lot of different fronts. The power station also, you would have seen the pictures of it, it's like a museum almost. It's still running, but it's like a museum. So we've got to do something about it, and if we're going to do something about it, maybe we should make it a bit more flexible and controllable, and maybe we could get more megawatts out of the station, because at the moment it's about 75, 80 megawatts we get out of the station due to the engineering. And don't forget, it's an 80-year-old asset. That building you saw actually is heritage listed, by the way. So it may turn into a hotel or a motel or something in the future, who knows. Okay, so the idea about Tarraleah is we actually replace the conveyancing systems, change the way these holding ponds work, and create a headwater storage that then directly connects to a new power station. Okay, so anyone who knows anything about hydropower, that disconnects the timing issue, so it allows you lots of flexibility. So your headwater storage becomes instantaneous control. That'll hold about 48 hours worth of storage. And then we can go from about 75, 80 megawatts in a power station to about 220. So lots and lots of really good reasons why we should be seriously thinking about redeveloping the Tarraleah Power Station. Tarraleah Power Station is the top of the Derwent as well. So the water that runs through Tarraleah then runs through cascades through all the other stations. They go all the way down through to Hobart. So it's a really, really important asset for us, both the power station and the water. Rightio, next steps. I got here. So Tas Networks are getting on with the interconnector, because we spoke about that. That's really the critical part. Everyone else is trying to fit into that, including us. We're going to get on with our assessment process on those 3 sites, because we want to choose one of those sites that will go first. And at the end of this year, we're going to form a view on what it is we're going to do about Tarraleah in terms of its future. And there's no do nothing decision there with Tarraleah. We have to do something. So there's no, the board can't say to me, Chris, don't like any of those ideas, just leave it as it is. We actually need to make a decision. So it's really important. And we'll continue to do this sort of stuff, as well as engage with the Energy Security Board and all the other market players, because the market is in transformation. And we need to engage in it to ensure we get a really good outcome for customers. That is the penstock for Powattina. Powattina is another one of our sites that were on our earlier list for pumped hydro. The top of this is Great Lake, which is a very, very large lake, not as big as Gordon, but still very large. That's why they call it Great. But we could potentially put a pumped hydro site in parallel with that power station as well. And I'll stop there.